Hello everyone. Welcome back to software design concept based videos. In the last video, we have seen about what is a cohesion and what is coupling, and as well as we have also seen what are the different types of cohesions and couplings. Now, in today's lecture, we are going to start with what is software architecture and how many types of different architectures can be there, as well as we are going to study about software patterns in the next video. What is an architecture? An architecture is not an operational software. Rather, it is a representation that enables a software engineer to analyze the effectiveness of the design in meeting its stated requirements. It can also be considered, we can also consider architectural alternatives at a stage when making design changes is still relatively easy, and it reduces the risk of associated with the construction of the software. Now, let us understand this particular definition with some examples. Suppose you want to create a particular module or software. Suppose you are going to write a program for finding the factorial. Now, factorial generally can be done without modules also, but yes, it is better to write it with modules or with functions. When in what case you should understand that I have a mean function which is actually taking up the number, and then I am passing this number as a parameter to the next function, the next module, right? So my main function is calling the functional function which actually computes the factorial, and this is the simplest architecture you can design, you can understand. So it is actually, if this was the design of the this was a design that resolved the problem, you actually tested the effectiveness of the design, and you actually understood that this design actually meets the requirement that is specified in the objective of the program. Secondly, if I say that now you don't have to use iteration in finding factorials, what is the other way that you can do with finding a factorial is using recursions, right? So this is the next architecture design. Now I will call the function, I will use recursion instead of iteration. So we can also consider it helps the in software engineer to actually restructure the or redefine the systems and find new architectural styles, right? We can implement the same solution using multiple other methods, and because I have multiple other methods to implement the same set of functionality, it actually reduces the risk associated with the construction of a software. If something fails at one style fails, the other style is always there as an alternative for me. So this architecture, when we design an architecture, we will actually consider all these factors, and because of this architecture of a software is so important. Now, the next thing is why this architecture is so important. Representation of software architecture are an enabler for the communication between all parties. That means all the stakeholders interested in the development of a computer-based system. That means that each and every person, like if we are designing a software for student management system, in a student management system there are multiple parties. They are not just teachers and students. There might be n number of parties involved in that student management system. Official staff actually do the clerical job, the teaching staff that actually teach the course, the management staff that actually runs the course, and then there's the students that are actually a part of the course delivery. So all these people are the stakeholders of the student management system. Now, it actually, whenever I draw a architecture, I should take perspective of all the stakeholders, right? Just not teachers and students, but yes, from all the perspective, I want to find out that everyone has a say in this architecture model. The architecture highlights early design decisions that will have a profound impact on the software engineering work that follows, and as important on the ultimate success of system as an operational software. So if your architecture is very sound and it is very proven, tested, right? It has all the viewpoints of all the stakeholders. It's going to work for all the people who are going to interact with the system, right? It constitutes a relatively small, intellectually graspable model of how system is structured and how component works together. So we will see in the future slides that what does this mean, right? Now, though there are multiple things, one is called architecture styles. We are going to discuss the styles in today's video. The styles generally describes a system category, and it has the following components. The first thing is it actually have certain set of components, that is database or computational modules that perform a function required by a system. So it might have if I say I have a student management system, so I have two entities, two modules, student module and a teacher module, as well as I should have some database to store the students information somewhere. So it has multiple components. It also has set of connectors that enable communication, coordination, and cooperation among the components. So it might have one way mechanism or two-way mechanism of interaction between the students and the teachers, suppose. Then it can also have constraints that define how components are integrated to form a system. If you are creating a system for counseling, it can be one to one and it can be a two-way communication, right? So that there's less constraint. But if you are having a lecture type of system, then in that case, you cannot allow question answers sometimes in between the session. So the constraint is the teacher can impose that it can close all the mics while the teacher is delivering a session, and when he wants he can enable and he can disable the mic as well. So there are certain constraints, might be possible it is a user constraint, or there can be something called design constraints also. And the last is it has a semantic models that enables the designer to understand the overall properties of a system by analyzing the known properties of its constituent parts. When I see a architectural style, I understand whether this type of system can be implemented. I can understand what is the logic behind implementing this system using this particular type of style. For example, I want to process, you all use YouTube. So instead of typing on YouTube, what you do, you press the mic button, you say your query, and the YouTube searches the video for you, right? So this is a particular, if I want to draw this as a diagram somewhere, so if you see the diagram, you understand, okay, this is what it is being doing, right? If you can understand this, the meaning of the system is very well conveyed, then the architectural style is very well suited. Otherwise, this is a complex system. So now we go back to one by one all the styles. First style is called data centered architecture. It consists of a data store or a file or a database or a repository which is site at the center of the architecture, right? The main purpose of the style is to achieve data integrity. That means the data cannot be changed on the fly, and if somebody changes, everybody else knows who have made the change. Data center architecture consists of different components that constitute through the shared, which communicate through a shared data repository. uh, this is the basic theory of all the data center architecture. Let's see a diagram. It's something like this. So it has a data store at the center of the system, and all the other components are the client softwares that actually accesses this data store. Now, data store can be either act as a repository or either act as a blackboard. So repository and blackboards are two different form of architecture. So if I made this data store as a repository, it behaves differently than in comparison to the blackboard. So what is a repository style? A repository style, in repository style, the data store is passive, and the clients are the active data stores, active data. So what do you mean by active? That means they are doing the processing and they are pushing the data towards the data store, and data store stores the data in as a repository, right? Now the course feedback can send a data in Word format. The approvals can come at another format. The reports can be in a PDF format. The registration can be a table. You can have multiple type of works that is pushed through the repository, and if anyone wants it, it can take the it from the repository itself. So this is a repository style when the client nodes are active and the data store is passive. On the other hand, Blackboard architecture is one in which the data store is active and the clients are passive. Therefore, the logical flow is determined by the current data status and the data store. It has a Blackboard component acting as a central repository, and an internal representation is built and acted upon by the different component elements. Uh, so these are the two basic broad type of data centric styles. The next is called data flow architecture. In data flow architecture, the architecture is applied when the input data are to be transformed through series of computational or manipulative components into output data, right? And it follows a pipe and filter structure that has a component called filters and connected through pipes that transmit data from one component to the component. Each filter works independently and do not require the knowledge of its neighboring filters. So it is somewhat like this. The diagrams have two things. One is called the pipe and filters, and they're called batch sequential data flow. Pipe and filters both have pipes and filters, but one which is shown in the A part is having more flexibility than the B part. In A, what you do is you are sending some data to the first filter. The work of the filter here is to filter out certain data and create a processed data, right? Suppose you are sending a query through YouTube. You open the mic, you said whatever query string you want to find, what a song you, what a video you want to find. You actually say it in words. Now, might be possible you doesn't pronounce it very clearly, or the system doesn't understand it very clearly. So the first filter is to process the audio into a proper text format. So the first filter will be doing this. The second filter will be extracting the keywords, suppose, and the third filter will be applying it to the search algorithms and finding out the relevant videos. So one by one, step by step, you are processing it from a very raw state to the actual process state. So once your information flow from a very raw state to actual process state to different pipes and filters, it is known as data flow architecture. The third thing is the third architecture is called call and return architecture, and you the first part of this you have been you have used it in your programming labs when you have created functions for different languages like C, C++, Java, Python. You have done this. So in that you have a main program and you have a sub program. This is the basic structure which says that the main program calls the sub program, and when the sub program is done, it returns back to the main program. This is one form. The other form is known as a remote procedural call, in which you have two different systems, right? A system is located geographically at a different states, right? Suppose you're sitting at your home and you want to work on a particular PC in your office. Then in that case, these you want to access some system remotely. Then you want to invoke a RPC, remote procedural call. That means a client function can access a server function. So whenever I have some sort of calling between two different nodes, right? Then I will use RPC. I can't use something called return and function call. Okay. So in RPC, the client function calls the client stub. The client stub actually calls the socket. The socket actually calls the server socket, and server socket actually calls the server stub, and then it's called the server function. The server function actually reads all those commands that has been given to the from the client and returns back to the server stub. Server step actually goes to the server socket, and server socket talk to the client socket, right? And then the reverse back goes to the client functions. So this is how a remote procedural call actually happens. And if you haven't seen this, you can use it using telnet servers, or you can use a remote desktop which was coming in Windows, which was a part of Windows some days earlier. So if you actually work with remote desktop, you should understand this particular thing. The last one is called a layered architecture. In layered architecture, generally this is followed when we create softwares, or when we create system software where we have different layers of software, right? Like some softwares are working close to the hardware, some software are working as an infrastructure, some software are working as a user based application level. So when you are having certain components which are at the user interface layer, these are different. Then you have an application layer, then you have a utility layer, and then you have a core layer. In layer architecture, number of different layers are defined, and each accomplishing operations that are progressively becoming closer to machine instruction set. So compilers are at a usability layer, okay, because they take an application, right? And the GUI that you create is a part of user interface design. The application that you create after the GUI is an application layer, like you create a logic for calculator, scientific calculators. The scientific calculator is an application, it has a GUI, so it is working in an application layer and a user interface layer. Now this calculator actually uses either interpreter or a compiler. So interpreter and compiler are at a layer of the utility layer. The utility layer actually breaks down the data and work with the core layer. The core layer actually works closely with the hardwares, right? So in short, you actually have a bundle of different layers that work together, okay, and to accomplish one objective, the simple set of objectives. So these are the four different type of architectures, like data center, data flow, return architecture, and layered architecture, that are part of an architectural style. Next, we will see architectural patterns in our next video. So hope to see you in the next video. And if I have any questions, you are free to ask. Thank you.